I am super curious. How many of you have used PortSentry before? No one. Okay, interesting. So, very high level overview, right? What it is, you define network ports that you want to listen on, and whenever traffic comes into those ports that you define, they will be logged, and you can also execute actions based on the trigger that happens. Right? That's the overview. So, what are the use cases for this? Well, one really good use case is enumeration prevention. So let's assume you have a VPS on the internet, maybe a web server. You could have PortSentry listen to all of the unused ports like Telnet, FTP, RDP, the Windows remote desktop protocol, maybe ALDA. Databases are popular, right? Redis had a security vulnerability a couple of, like a year ago or whatever. Just listen to those ports, and whenever there's an incoming connection, you ban the IP addresses. This will prevent scanners from enumerating what ports you are providing or what services your VPS are providing. But there's a little bit of a hidden use case in this enumeration prevention, and that is if you are targeted by an adversary. One of the first things that an adversary will do to try to get into your network is to enumerate what kind of services you're using. So you will basically make it extremely difficult for them to enumerate what you are running. It's not a foolproof, of course, but it's a small little cog in a huge cybersecurity frameworks and applications that are out there. There's another use case which I like even more, and this one is really great. It can be used as an intrusion detection tool. Just spin up PortSentry in your internal networks in your organization. Listen to the LAN, listen on your VPN, listen on your management networks, your Wi-Fi's, everything that you use internally, right? And then just define a couple of ports like SSH, Telnet, whatever, right? Those IP addresses that you spin up PortSentry on, they should never be used within your organization. You have a dedicated IP address which is not used in your organization. But if an attacker comes into your organization, one of the things that they will do is try to look around your network. They will scan it. So when they hit your PortSentry dedicated container or virtual machine that only listens to these ports, well, just trigger the alarm, and you know that something is very wrong within your network, right? I added this little slide here. I think it's kind of fun to see statistics. Like if I put PortSentry out on my VPSs and my public-facing networks, I will get pretty interesting. I can identify trends and maybe anomalies and things that, like new things that adversaries are trying by just analyzing what sort of ports they are trying to connect to. Maybe not as useful, but yeah. So that's a little bit of an overview what you can use it for. And here's the history. It has a rich history. That's why I wanted to know if anyone had used it before, because the project started in 1997. And it was part of this Abacus company, which got bought out by, I think, Cisco, but I'm not sure, in 2003. And Cisco, or whatever company bought it, they didn't want to keep maintaining PortSentry, so they switched to an open source license, put it on the... And it was open source in 1997 as well, but maybe they were selling support or something for But in 2003, they abandoned it and licensed it under a very simple license. I think it was the common public license. And yeah, it was maintained until 2023, when I wanted to upgrade it, because I have used it for a long time, since the 2000s at least. And very soon, I'm happy to announce that I am ready with version 2.0. I've been working on it for 2.5 years, so version 2 will have probably some nice features. But the old version, version 1.2, is still available. It's available in the Debian repos, so it will be in Ubuntu and all of the spin-offs for Debian. It's available in OpenSUSE, NetBSD, OpenBSD, and even Gentoo has the source in their repository, so you can compile it. So like I said, I've been a user for a long time, and this was me in 2023, where I said, you know, I need just a couple of features. Maybe I'll just be the new maintainer for PortSentry and just add these little features and put it on the internet so everyone else can enjoy them. Little did I know that there were some issues in the code base. Yeah, I had to fix those. That's why it's taken 2.5 years to almost having version 2.0 released. Let me go through them really quick so you know what you can expect. I fixed inconsistencies. There were potential resource leaks, race conditions, input validation issues, code consolidations, and when I really dug into the code, I realized that it could be optimized a lot. I'll show a graph later. And I also removed legacy code because when it was released in 1997, it had support for HP, Unix, ERIX, NextStep, etc. And those platforms complicated things, to say the least. So I actually removed support for that. So you can't use the new version in NextStep or HP, Unix, and some others. But it would probably compile, but yeah. I switched to CMake. I added linting and formatting, and I started doing integration tests and fuzzing, also static analysis of the code. Did a little bit better logging, and I also added the documentation. Being a long-time user, I sort of had a very good working knowledge of how PortSentry worked, but I realized that there are a lot of scenarios, like the use cases I showed you before, which people might not really get. So yeah, I added that. But now to the features. The new features in PortSentry 2.0 that I wanted to add is libpcap support. In case you don't know, libpcap is a library to talk to the kernel's EPF engine. What does that mean? Inside the kernel, both on BSD and Linux, there's this little packet filtering engine. If you ever use TCP dump, you have used libpcap and the DPF engine. It basically allows you to tap into all of the network traffic and write filters for it to see what kind of traffic comes in. And since this happens in the kernel, it's a lot faster than if you're doing it in user space, right? I also needed IPv6 support, so that's added, and I also added Docker integration, and I'm happy to say that we are on Docker Hub, so now it's, deploying PortSentry now is as easy as doing docker run PortSentry/PortSentry. I also added fail to ban integration. I'm a huge supporter of fail to ban. In case you don't know, fail to ban will read any log file you ever have, and you write a little regular expression, parse out stuff from the logs, and then you can basically run different actions on it, like IP tables to ban an IP address or whatever. And the nice thing about fail to ban is that if you reboot your computer, it will remember the IP addresses that have already been in the log files and re-ban them. So your firewall will always be up to date. And it will also remove them. You can set how long you want an IP address to be banned, and it will remove it once the timeout is done. So like I said, version 2.0 is imminent, and these are the very unscientific profiling that I did. On the left here, you see version 2.0 in PCAP mode and also in raw mode. It's 2 modes. It doesn't really matter for this slide. I managed to cut the response time per packet down by half. So I'm pretty. I want to get under 0.2 milliseconds. So hopefully I can do some further optimizations to get it down a little bit more. But it should now be fairly ready for like a gigabit traffic. So this talk promised to talk a little about the lessons that I learned supporting multiple Unixes, because one of the reasons I did this also was that all of the BSDs, they had lacked features that only were available in Linux. So I wanted to bring up the BSDs to the same level as Linux. And even though Unix is supposed to be Unix, I have learned that Linux is not the same thing as BSD. And BSD might not always be the same as OpenBSD. OpenBSD is very different. In case you don't know, OpenBSD is worth it though, because they place a lot of focus on security in their distribution, or their version of Unix basically. So supporting OpenBSD for me is very important. I also learned that libc is not always libc. This was a very surprising moment for me. There is one function missing in NetBSD's version of libc. I haven't gone into the details, but it might be something, if you ever do cross-compiling to Linux and you want to support BSDs as well, you might be aware that there are a little bit inconsistencies. So BSD uses C-line, and Linux obviously uses the GNU compiler. They are surprisingly compatible. They can almost be working interchangeably. There are some warnings and error differences in C-line and UCC, but this almost always makes your code more robust and portable if you take into account both compilers. Also, C-Lang's behavior changes more between versions. Like NetBSD has one version and FreeBSD the same, and OpenBSD lags a little bit behind in the C-Lang version, so there could be some inconsistencies there. BSDs are more stingy with header files. Obviously, I'm talking, I forgot to mention, I have written, PortSentry was written in C, and I have continued writing in C, but most of the things that I talk about here, if you're doing system-level programming to the kernel or to the POSIX interface, it will be the same things, right? Maybe not these include headers, it's just a minor point. BSDs are more stringent with how you include header files. For example, there's this header file called types.h, which basically includes a lot of different types that you can use in your language, and that's not automatically, like in Linux, it will include types.h where it's needed, but in FreeBSD you have to include it manually. But it's just a compiler warning, so it's easy to fix. Also, when you're working with IP addresses, there is a structure in the kernel which basically gives you like a pointer into the various fields in the IP structure. For some reason, Linux has its own format called IP header, BSD has another format called just IP, but Linux also has this IP structure. So if you're ever doing any sort of network coding with IP addresses, remember that use the struct IP, because then you will automatically get compatibility with BSD. Here's a huge difference between Linux and BSD. If you open a socket to the kernel and you use the AF packet socket, then Linux will just forward all of the packages coming into your machine from all of the interfaces, right? But BSD will not do that. And that is the core reason one of the core reasons why I wanted to upgrade PortSentry a little bit. Because in this case, PortSentry wants to have all of the packets, right? So you can identify which packets you should sniff and take actions on and log, right? But on BSD that was not available. There is also this interesting differences in kernel events. Linux has this AF netlink socket, which will tell you about when stuff happens on your computer. Like if you add an interface or you add an IP address, remove an IP address from an interface, the kernel will tell your program about this. And the BSDs, they have a similar kind of interface called pfroute, which will tell you when network interfaces are coming and going, when IP addresses are added, or routes and broadcast addresses and whatever. But BSD, for some reason, have very inconsistent use of this interface. And here's a little interesting slide that we're not going to spend much time on. But if you like a mystery, if you're a mystery solver, you could help me out here, so I don't have to do this, because this is the current version of the code, which works, but it doesn't look good. So, for those of you who don't know C, the first part here, if the NetBSD, is like the BSD version of how you should increment around all of the messages that the kernel sends you, right? And if you happen to be, if your message is an RTAX IFA and it's an IPv4 address, then you should increment by doing the size of the socket address buffer plus the 16 bytes. If it's an IPv6, then you add 32 bytes. If it's something else, you add 16 bytes. And if it's not an RTAX IFA, then you should use this macro called RT roundup2. There's also a macro called RT roundup. I have no idea what the differences are. And of course, if you are using a FreeBSD, then you should always increment your counter by SA size macro. And if you're an OpenBSD, you use the roundup macro, not to be confused with the roundup2 macro. So yeah, it's very interesting, but this is very specific for the kernel interface for BSDs. I thought it was a fun thing to show how it can differ a little bit. Anyway, libpcap is an abstraction library, so you're supposed to be able to, any platform that implements libpcap, if you write your code to libpcap, you should get the same functionality across all platforms. But it's not always the case. It has a little bit of small differences. BSD has small nuances that you have to take into account, but they are documented. There is one problem though. OpenBSD, for some reason, decided to fork libpcap in 1996 at version 0.5 or something, 0.6, I don't remember, which makes it very different from the upstream version of libpcap. So if you ever do libpcap stuff I would recommend a lot of testing on OpenBSDs when you write your application. There is also called IPv4 and IPv6 dual stack in the kernel. So basically, if you listen to an IPv4 socket, you will get IPv4 packet, standard stuff. But in Linux, if you listen to an IPv6 socket, you'll get both IPv4 and IPv6. But in FreeBSD and NetBSD, you have to check if the kernel has a flag set to also include IPv4 traffic on the IPv6 socket. So if you open an IPv6 socket on BSDs, you have to also make sure that the kernel is configured to forward IPv4 traffic. And you can turn it off, like if you're only interested in IPv6, you can turn it off. So it's like a setting. And it's also available in Linux, but the difference is that they have different defaults. OpenBSD, for some reason, said no. We don't allow dual stacks. So if you want to listen to both IPv4 and IPv6 traffic, you have to open different sockets. So here's my takeaway from doing cross-Unix system coding for 2.5 years. It's not like rocket science and you have to be like a guru at the different Unixes, but it helps to have virtual machines running with all of the supported platforms that you're running, and as soon as you can, just compile to all of the platforms, because there's always going to be some warnings, and you want to catch them early so they don't cascade, and you can fix them. I want to end by just talking a little bit what's coming around the corner, or what's next for PortSentry. Like I said, version 2.0 is, days or weeks away from being released. I basically only have documentation and doing long-term testing left, and I would appreciate it immensely if you think that this is interesting. Download the master branch on GitHub, or just do docker install unstable, because unstable follows the master branch. And test it out and give me feedback if you can. I want to do Prometheus and Loki integration in the future. I already do Loki integration for myself. Loki, for those of you who do not know, is a log-centric application, right? So it will collect logs from various different places. So you have all of the logs in one place. That's Loki, right? It's a log database. And of course, you can use other tools like Grafana to visualize the logs, right? So what I do is I extract the port numbers, and I try to graph out like which ports are most popular to attack right now, etc. That's what I talked about earlier with the statistics. So I'm going to do proper integration with that and release that as well, so you can also have nice statistics in your organization, perhaps, at least for the public facing. Right? I also want to do the application multi-threaded. Right now it's not. That will increase, hopefully, speed a lot. With that, I would like to thank you for listening to my talks. And help is wanted. I'm by myself in this project. There's a lot of things to do. And if you're interested at all in network security or testing would be great. Please contact me, email me, or just go to the PortSentry website. And I guess we have like 5 minutes for questions, if there are any.
Thank you.
Thanks.
Right, questions?
You weren't first. So there's two questions. So you mentioned performance. What are the techniques you have found that were quite useful within PortSentry to gain the performance you have now? And since you also mentioned the multi-threading, what thread architecture are you looking at to introduce the PortSentry to improve performance further?
Right. Well, first of all, the old version of PortSentry, it actually reparsed the configuration file, the text configuration file for each port, for each connection attempts that got in. Now, anyone who knows anything about hard drives is that it's 10 million times slower than doing stuff in RAM. So the first thing I did was to just parse the configuration file and put it in RAM, right? But that's obvious. But what I did was I tried to analyze the logical flow because there's a lot of checkpoints that the packet has to go through. And I tried to identify things where I could dismiss the packet as soon as possible if it's not interesting enough, right? I also implemented some caching. So for example, there are, like if a packet has already been seen on a certain port from a certain IP address, I'm not interested in it. So that way caching can be used to dismiss it. But I think that logical flow analysis and perhaps implementing caches at strategic points is like the big thing. Regarding multi-threading, you know, I don't know really, but I'm thinking about releasing version 3.0 in Rust because I think that Rust it has a future, I think, and it's very interesting. So in that case, Rust has very, very good support for multi-threading.
Thanks. We have one more over here, I think.
Like we've been talking about performance before, have you considered moving some stuff more towards the kernel, because like eBPF and so on, because I imagine the context switching of the packets coming in, going to user space and so on, and then taking action on them, increasing quite significant overhead.
Yeah, I moved everything to BPF. So when you use libcap, you basically you basically program the BPF engine in the kernel. So a lot of stuff is blocked in the kernel space.
Okay, so that also includes taking action, or is that in the user space?
No. Taking action is in user space. I have no idea how I would take action in kernel space. If you have any ideas, I'm very interested in them.
Thank you. We'll have to stop there to make space for the next talker.
Great.
Thank you very much.
Thank you.